Bismillahirrahmanirrahim. Today we are going to speak about the normal distribution. If a random variable has a probability distribution whose graph is continuous, bell-shaped, and symmetric. So we have these three conditions. The graph is continuous, it has bell-shape, and symmetric is called a normal distribution. So the normal distribution is just a distribution that satisfies the three conditions. The graph is continuous, bell-shaped, and symmetric. Symmetric about the mean of the data. It's called normal distribution. The graph is called a normal distribution. So this is the shape of normal distribution. Bell-shaped, continuous, and symmetric. Symmetric means the left side is coincide with the right side. They are matching. We have some properties for the normal distribution. A normal distribution curve is bell-shaped. This is the first one. The mean, mode, and median are equal. This is 3. Mean, mode, and median are equal and are located at the center of the distribution. All of them are equal. A normal distribution curve is unimodal. It has only one mode. We say that the mode is the value with the highest frequency. For the normal distribution, we have the mode only with one frequency, to repeat only one time, or just one value has the highest frequency, only one value. Because we know that for the sum distribution, it is bimodal or trimodal. 3 values or 2 values have the highest frequency. But for the normal, it is only one value has the highest frequency. The curve is symmetric about the mean. If we divide this into parts, we see these are symmetric. Before the graph about the mean, they are coincide. The curve never touches the x-axis. This is the x-axis. So the curve is almost touched, but it is not. So it's very close to the x-axis, but it is not touching the x-axis. Some other field we will call this is horizontal asymptote. X is the horizontal asymptote for the graph of the normal distribution. It is not touching the curve. The total area under a normal distribution curve is equal to 1 or 100% in the probability. So the area is 1 or 100%. The area under the part of a normal distribution that lies within 1 sigma of the mean is approximately equal to 0.68. 1 sigma means the standard deviation. We mean the standard deviation. So if we take 1 sigma from left and right, so within 1 sigma from left and right is about 0.68. This area will be about 68, so it is point, we can say. If this is a normal distribution, this is the mean. So it will be 1 sigma from left, 1 sigma from right. This will be 34%, and this is 34%, or 0.34 and 0.34. So 1 sigma to the left or 1 sigma to the right will have the area equal to 0.34 and 0.34 to the left. The standard normal distribution, standard normal now. Speak about the standard normal. It's a normal distribution with a mean of 0 and a standard deviation of 1. If we have this value, the mean equal to 0 and the standard deviation is equal to 1, we call this a standard normal distribution. One feature is added now. Mean equal to 0 and standard deviation is equal to 1. All normally distributed variables can be transferred into the standard normal distribution variable. Just find the z-score. Any normally distributed variable can be transferred into the standard normal distributed variable that using the z-score or z-position or standard position we said before also. So the z-score is equal to x minus the mean divided by standard deviation. This will convert any normal distribution to the standard normal distribution. Now to find the area under the standard normal distribution curve, we have 3 cases. To find the area under the curve, we have 3 cases. The value will be to the left of the any z value. So with that, we need to find the area, and that value is to the left of the z-score. We'll have x is less than z. If it is to the left of the z-score, the area can be given directly from the table of the normal distribution. I'm going to speak about this one just in a few minutes. We have table already made, calculated for the normal distributed, where we will have z and all the area under the curve using any value for z, from minus 3.4 up to plus 3.4. So, and this value is given the area under the curve to the left of the z. All of these to the left of the z. So if we need to find the area under the curve to the left of any z value, just go for the z or for the normal distribution table and look for z, and the given value will be the area under the curve. Now the second case, if it is to the right of the z, look up for the z value and subtract the area from 1. So the area will be in this case 1 minus what's given in the table is the left area. If we need to find the right area, we have to subtract it from 1. If it is between 2 values of z, look up both z values and subtract the corresponding area. So what this is will give me A1 and this is A2 from the table. The area will be A2, the larger minus the smaller one, the right one minus the left one. And you have to keep in mind one thing. For the z-score, the mean corresponds to z equal to 0. This is not good one, should be. The mean is corresponding to z equal to 0. The right area is 0.5. Left area is again also 0.5. Because we say the normal distribution is symmetric about the mean. So the left equal to the right, and both of them are equal to 0.5. Left area equal to 0.5, right area equal to 0.5. Now let's explain this by solving some examples. I need to find the area under the standard normal distribution curve to the left of z. When you say to the left of z, it's just a graph the normal distribution here. And I have some z 0.37. Z can be positive value and it can be negative. If x is less than the mean, it is negative. If it is greater than the mean, it is positive. And if you see z is positive, so the area will be greater than 0.5 for sure. If it is positive, it will be greater than 0.5. because the z equal to 0 is in the middle. This is z equal to 0, and we are looking for z equal to 0.37. Say somewhere here, this is 0.37. And to the left means I need to find this area, which is 0.5 plus this one. So this is to the left. When you see this to the left of z, means go for the table and pick the value from there directly without doing anything. So if we go for z equal to 0.37, this is the 37. Column here will give me only one decimal place. The second one will be in the horizontal one. So 0.37, let's go for 0.37. Go down, this is 0.3. We have z equal to 0.37. The first digit we'll find in the first column. This is 0.3. 0.7 will go for the horizontal one to find 0.7 to 0.07. Because this is equal to 0.3 plus 0.07. 0.37 is 0.3 plus 0.07. 0.3 will be in the first column. And for 0.07, we will look at the horizontal one to find it. And see the intersection between these two, the row and the column. It is this value, 0.6443. So the area under the, or to the left of 0.37 is 0.6443. In this case, area. And also this is the probability. We'll see later on, this is the probability of normal distribution. Must be the area. A equal 0.6443. Now the next one to the right of Z. To the right of Z is minus 1.87. Mean is 0. And minus mean will be to the left of the mean. It is somewhere here. This is minus 1.87. And we need to find to the right. To the right means I need to find this area. This is the second case. If it is to the right, so the area will be 1 minus some value. That value we will find it from the table, from normal distribution table. I have z equal to minus 1.87. I said that all the values given in the table are to the left of the z. But now I need to find to the right, so I have to subtract from 1 minus that value. If we go for the normal distribution table, I have this in this case equal to minus 1.87. I will look for 1.8 in the first column, or minus 1.8. Minus 1.8 is this one. And 7, it is 0.7, this one. Take the first two digits in the first column, and third digit, look at it in the horizontal one. Now the intersection between this column and this row is 0.0307. This value is to the left. And in our question, we need to find to the right, which is 1 minus this one. This will be 1 minus 0.0307. Again, if we want to find to the right, we have to subtract that value from the 1. And this will give me 1 minus 0.0307 equal to 0.9693. So I have one more. Between z equal to 0 and z equal to 1 or 1.07. Z equal to 0 and z equal to 1.07. So I have two areas here. And I need to find the difference between the larger one, A1 and A2. We said that when z equal to 0, if z equal to 0, I will have A equal to 0.5. I will get 0.5, either positive or negative. So when z equal to 0, the area equal to 0.5. Now I need to find the second area, which is at when z equal to 1.07. This is positive. So we go for 1.07. This is 1.0 and 7. So it is this one. And this, which is 0.8577. This will give me A is 0.8577. So the area is the larger one, which is 0.8577 minus 0.5. That will be 0.3577. This is if it is between two z values. One more example. Let's take 2. Between z equal to 0 and z equal to minus 0.32. Now this one, say, equal to 0.5. Now z equal to 0.32. Again, we are speaking about two values, z equal to 0 and z equal to minus 0.32. And to find the area between these two values. For the first one, I got A1 equal to 0.5 for minus 0.32. Let's go and see minus 0.32. So this is 0.3 and this is 0.02. Sorry, this is a positive. I need to look at the negative one. This is minus 0.3 and 0.02. This is the third one. This is 0.1. It is this value. We go up. This will be 0.02. Because our z is minus 0.32. So 3 in the first one and go for the horizontal, which is 0.2. I will get 0.3745. So the second area is, this is A2, 0.3745. Yes. So the area between these two will be 0.5 minus 0.3745, which is equal to that will be 0.5 minus 0.3745 equal to 1.1255. between z equal to 1, 0, 9, and z equal to 1.83. Okay, this is the last one. I have z equal to 109. .09 is the last one. This is 1.0. And 0.9 is the last column, which is 0.8621. So this one will give me 0.8621 or 21. And the second one, z equal to 1.83. 1.8, this is 1.8, and this is 83. This is 0.03, which is 9664. This will be 0.9664. So I have two values. First one, this is A1 equal to 0.8621, and A2 equal to 0.9664, and this will give me, the area will be just the difference between these two. The larger one, 0.9664 minus 0.8621. It is between two. So it is the larger one minus the smaller one, and that will give me 0.9664 minus 0.8621. That will be 0.1043. And this is the area between these two z-score. So all what we did now, you just find the area using the normal distribution table, either to the left of it or to the right or between two values. All the values given in the table are to the left of the z-score. If it is to the right, we have to subtract that one minus what's given in the table. If it is between two z-scores, we subtract the larger one minus the smaller one, and that will give me the area under the curve of the normal distribution. As I mentioned before, these values or area sometimes will be used in the future, in the coming lecture, as a property of normal distribution. We will use these values to find the probability of the normal distribution, and this will be explained in the coming lectures. So that's it for today.